out of the office on February 17th, so instead of a live session, we will have this recording. If you have any questions, you can send me a K-mail, and I will be in live help on Wednesday. So, with the topic 3.07, decimal numbers. This is really about a concept called scientific notation, which is a way to write really, really big numbers or really, really small numbers much more quickly. So here is a big secret. I think I've let you guys know about this before. Mathematicians and scientists are kind of lazy. And they didn't want to write out these big numbers, especially if you have to do it several times. So they decided to use the power of 10 so that they could create short versions of these really, really long numbers. So there's some rules for scientific notation. To be in proper scientific notation, the number must be written with a number between 1 and less than 10. And then it's multiplied by a power of 10. So a number like 1.7 times 10 to the third is written in proper scientific notation. However, 23 times 10 to the fifth is not. Why isn't it? 23 is 10 or larger, and that is not allowed. However, 2.3 times 10 to the sixth is, and it's exactly the same number, and I'll show you how they do it. So, if we have a number 137 million, we could rewrite that as 1.37 times 10 to the eighth. Isn't this a lot easier to write than that, trying to keep track of all of those zeros? Now you may be wondering, how is that possible? How did what they do pass the math legal test? Well, 1.37 times 10 to the eighth. What is 10 to the eighth? Well, it's really 10 times 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 10. 10 times itself 8 times. And if you were to have your calculator out and put in 10 times 10 times 10 8 times, you would end up with 100 million. Now, what is 1.37 times that 100 million? You're right. That equals our original amount right there. That's how it's lazy. Who wants to multiply that out each time? I don't. Mathematicians don't. We could do this out each time, but instead it's so much easier to just count the zeros. So, our original number there. Right now, the decimal point is right here. Now we know in scientific notation it has to be bigger than 1 and less than 10. So we want a decimal to end up right there. How many places does it have to move? 1, 2, 3, 4, 5, 6, 7, 8. I moved it 8 times. 1.37 times 10. That's right, we moved it 8 times. Our exponent will be an 8. So, is 1.37 times 10 to the 8th the same thing as 1.37 to the 8th? The answer is no. Yeah, we pushed laziness too far. That is not the same thing. If we had 1.37 to the 8th, what is that really? 1.37 times 1.37 times 8 times. Please don't make me write them all out. You guys know what's happening there. And if we push that into our calculator, would we come back with 137 million? No, we would not. So, now you try, although you can't in the recording, but I would suggest you push the pause button, try them, then push play again to see if you did this correctly. So, how would we write this in scientific notation? 1, 2, 3, 4, 5. We need to move the decimal point 5 places. 3.47 times 10 to the, you guessed it, fifth. Right here, 1, 2, 3, 4, 5, 6, 7, 8 times. We need to move the decimal 8 places, so we have 10 to the 8th. 1, 2, 3, 4, 6.14 times 10 to the 4th. 1, 2, 3, 4, yeah. My short-term memory dumped. Now notice here, I didn't just put 9.0. I used all of the significant figures. I just got rid of these empty zeros. Okay. How do we convert these back to regular numbers? We have to move the decimal point back. In this case, 5 places. 1, 2, 3, 4, 5 places. 1.23 times 10 to the 5th is the same thing as 123,000. We need 6 places. 1, 2, 3, 4, 5, 6. Put in some commas. 6.806 times 10 to the 6th is the same thing as 6,806,000. Okay, try these. How would we say this in scientific notation? Move the decimal point 3 places, 10 to the 3rd. How do we convert this back? We move the decimal point the other way. 1, 2, oops, we need one more. 2,480. 6.123 times 10 to the 6th. We need to move the decimal back 6 places. 1, 2, 3, 4, 5, 6. 6,123,000. How to express 306 million in scientific notation? Move the decimal. 1, 2, 3, 4, 5, 6, 7, 8. 3.06 times 10 to the 8th. All right. I hope you're getting the hang of this. If you're not, please stop by Live Help on Wednesday. Some word problems. In the United States, there are 15 million households that use private wells for their water supply. How would we write this number in scientific notation? Move the decimal. 1, 2, 3, 4, 5, 6, 7. That's the same thing as 1.5 times 10 to the 7th households using private wells. The U.S. has a total of 1.2916 times 10 to the 7th acres of land reserved for state parks. How would we write that in standard notation? Move the decimal back. 1, 2, 3, 4, 5, 6, 7. Commas, commas. 12,916,000 acres. Why does a negative exponent give us a small number? Well, if you look at it, 10,000 is 10 times 10 times 10 times 10, or 10 to the 4th. 1,000 is 10 times 10 times 10, or 10 to the 3rd. 100 is 10 times 10, or 10 squared. Do you see a pattern? These exponents are getting smaller each time until we get to 1, which is 10 to the 0. So, what is 1 divided by 10? It's 10 to the negative 1. 1 over 100 is the same thing as 1 over 10 squared, which would be 10 to the negative 2 exponent, and so on and so forth. As these exponents get bigger, because the denominators get bigger, the exponents get smaller. Well, they increase in negativity. So, we can also use this to write incredibly small numbers. 1, 2, 3, 4. Remember, it has to be a number followed by a decimal point. How many places did we move it? 4. but we moved it smaller. This is a small number. 8.82 times 10 to the negative fourth. 1, 2, 3, 4, 5, 6, 7. 5.9 times 10 to the negative 7. 1, 2, 3, 4, 5. 4.0 times 10 to the negative 5. Playing with exponents, I think, and the scientific notation is kind of fun. You just need to keep track of which way you're moving your decimal point. So here are a few examples. Press pause, trying to do them on your own. 1, 2, 3, 4. 4.0 times 10 to the negative 4th. Transferring this back, we've got, oh, I need to make this over here because we're going to have to add zeros. Right here, the decimal's right here. We need to move it. 1, 2, 3, 4, 5, 6. It's the same thing as 0.000001248. Yuck. Yeah, scientific notation really helps. Again, we'll have to move the decimal point back. 1, 2, 3, 4, 5. I should have written the zeros in as I did it, like before. 0.0000612. 1, 2, 3, 4, 5, 6. 3.06 times 10 to the negative 6th. 1, 2, 3, 4. 8.92 times 10 to the negative 4. All right, story problems. The nucleus of a human cell is about 7 times 10 to the negative 6th meters in the diameter. What would that length be in standard notation? Well, we have 7.0, and we're going to move it now back. 1, 2, 3, 4, 5, 6. 0.00007 meters in length. A ribosome, another part of the cell, is about don't make me count how many zeros there are, of a meter in diameter. Let's say that in scientific notation. 1, 2, 3, 4, 5, 6, 7, 8, 9. We would have to move that 9 places to the negative 9th. Small, teeny numbers that are smaller than 1 will have a negative exponent. Now, what if you were given something like this? And I do believe there are a couple of quiz questions like that. How could we add this to this? Well, first of all, let's get them to be in the same base. Right now here we have 10 squared and we have 10 cubed. But notice this is 42 times 10 squared, which is the same thing as 4.2 times 10 cubed. Now we could add them together because the exponents are the same. The base, the 10 to the exponent is the same. So 39 times 10 to the cubed plus 4.2 times 10 cubed. That gives us 0.2. 9 plus 4 is 13. 43.2 times 10 cubed. Now technically that isn't standard scientific notation because 43 is larger than 10. But we can move it 1 decimal point and get it 4.32 times 10, and we need to increase this one because we moved it 1. 10 to the 4th. Okay, if you have any questions about scientific notation, send me a K-mail, and I will be back in the office for live help on Wednesday.